This is Sarah Wilkinson from Humber College and the University of Guelph-Humber. Today I'm going to be teaching how to convert VO2 values, both absolute to relative and relative to absolute. I'm going to start off with a little bit of a background on what is VO2. VO2 we can define as the volume of oxygen consumed per minute. So what we use this for is to indicate measurements of aerobic fitness, so VO2 max, but we can also do VO2s at different exercise intensities or rest. So for example, I can measure your VO2 at rest, and for most people the average value relative is 3.5 mils per kilogram per minute. So most of us, if we express our VO2 relatively, we'll all have around the same resting relative VO2. This is equivalent to about 1 mat. I can also put you on a cycle ergometer and make you exercise at different exercise intensities and measure the volume of oxygen your body is consuming at those different exercise intensities. We need to be able to convert absolute values in liters per minute to relative values in mils per kilogram per minute to be able to compare between two different sized people. So for example, let's say I have Sally and I have Jane. If Sally is 55 kilograms and Jane is 75 kilograms, obviously Jane will likely have a higher absolute VO2 because she's a bigger person, has more muscle mass, and therefore will be consuming more oxygen. But I want to be able to compare these two women, and so I'm going to divide their absolute VO2 by their body mass to be able to compare the two of them. So I'm going to teach you how to do this right now in this quick video. I'm going to go very slowly and hopefully teach you how to do this without having to use any formulas. So we're going to talk about how to convert VO2 values without a formula. Just to start off, I'm going to talk about some basic mathematical principles. If I have two fractions, A over C and B over A, and I'm multiplying them, what I would do is I would multiply the two numbers on top, so therefore the two numerators, A times B, and I would multiply the two numbers on the bottom, therefore the two denominators, C times A. So I'd be able to express it, what's on the left, A over C times B over A is the same as AB over CA. At this point, I know that I can cancel out the two like numbers. So A and A will cancel each other out. So you can either express it like it is on the right or on the left, same thing. I can cancel out the two A's. What does this give me? It's B over C. So I can cancel out if there's a numerator and a denominator of the same unit, number, letter, whatever it happens to be, they cancel each other out. So we're going to be doing the same thing with unit conversion. So I'm going to start off with converting an absolute VO2 in liters per minute to a relative VO2 in mils per kilogram per minute. So like I said, we're converting liters per minute to mils per kilogram per minute. So let's do an example. Let's say someone has a VO2 at a particular exercise intensity of 2.1 liters per minute. And we can say that that's 2.1 liters per 1 minute. Normally we don't put the 1 in, but it actually means per 1 minute. What I want to be able to do is cancel out the liters because I'm converting to milliliters. So using the same principle I showed you before, we're going to be converting to milliliters. And if we want to get rid of liters, it's on the numerator to start with. Therefore, it has to go on the denominator later on. We know there's 1,000 milliliters in 1 liter. And using these principles we talked about before, the liters will cancel out because they're on opposite sides. Once we cancel out the liters, we're going to be left with milliliters per minute if we stopped at this point. So how this works is I take the top numbers, 2.1 times 1,000, so the numerators, I multiply them out. So that gives me 2,100. And I multiply out the bottom numbers, which is 1. 1 times 1 is 1. So if I stopped at this point, I'd end up with 2,100 milliliters per minute. However, that's not a relative value. Remember, relative values are mils per kilogram per minute. So therefore, I need to somehow insert my kilograms here. If you don't know whether to divide or multiply by kilograms, this is a pretty straightforward way. So if I set up my units the same way, I'm going to have to put in one more conversion factors. As you can see, kilograms has to end up on the denominator. So therefore, I'm going to put it in on the denominator here. I'm going to put in 1 on top because it's going to be 1 over 70 kilograms. I'm just putting in 70 kilograms here. So like we did before, I'm going to take all the numbers on top and multiply them out. 2.1 times 1,000 times 1 and divide by all the numbers on the bottom. Divide by 1, 1, and 70. And obviously, I don't have to be dividing by the ones. I can just divide by 70, which will give me 30 mils per kilogram per minute. As you can see, what we've done here is we've converted 2.1 liters per minute, and we've converted it to the relative VO2, 30 mils per kilogram per minute. Let's do a practice question. If I said Amelia has a VO2 max of 3.1 liters per minute, that means that's her maximal ability to consume oxygen. Her body mass is 65 kilograms. And I was to ask you, what is her relative VO2 max? Instead of just watching this presentation, I want you now to pause this video and try it out yourself. Once you've come up with a solution, or if you get stuck, come back to the video and the answer will be there. So setting this up just like we did before, I'm converting an absolute value of 3.1 liters per minute to a relative value of mils per kilogram per minute. We don't have the value yet. So if you set it up on the left-hand side, there's 3.1 liters per 1 minute of oxygen consumed to mils per kilogram per minute. So there's 2 conversions I need to make. Doesn't matter the order. So the first thing I'm going to do is I know I need to convert liters to milliliters. How do I know the liters has to go on the bottom? Well, it's because the liters is on the top before. So remember, I can cancel out 2 things. Liters on top, liters on the bottom. So liters on the numerator, liters on the denominator. And I know how many milliliters there is in 1 liter. So there's 1,000 milliliters in 1 liter. So I can cancel those 2 out. Now, if I stopped at this point, I would just end up with mils per minute. So I need to divide by body mass. The reason why I know I need to divide by body mass is that it's on the denominator for what I need to convert to. Okay, so she's 65 kilos. So if I take 3.1 times 1,000 and divide by 65, I don't have to worry about the ones here because anything multiplied divided by 1 is the same number. So I take 3.1 times 1,000 divided by 65, and I end up with 47.2 mils per kilogram per minute. So what we've done here is we've converted 3.1 liters per minute to 47.2 mils per kilogram per minute. This is a quick and easy way to not have to memorize any formula to be able to convert absolute to relative.